Okay. Hello, everyone. Myself, Dibyansu Srivastava, and today I'm going to teach you some type of. So let me check on YouTube. It is clear or not. So everything is fine. Now, and voice is clear. Let me check it. Everything is fine. Okay. So students, this topic for our B.Sc students, So this topic is related to a type of matrices. So before we study some topic related such as we complete from raw matrix. I proceed my lecture on. Today we are starting with our lecture diagonal matrix. Okay. So for diagonal matrix, we study about some related to entries. Okay. I'm say you some principal diagonal. Okay. So let us discuss about the principal diagonal. Okay. What is principal diagonal? So principal diagonal is nothing but it is the principal diagonal. It means let A is equal to Aij and their entries are square type matrices and cross an Bayes square matrix of order n. These are principal diagonal matrices. And why we say that this is a principal diagonal? Because its entries are a square matrix and the collection of all entries of matrix where row number is equal to number of column. Okay, so called as it is the principal diagonal. That is a collection of entries where I is equal to j. It means ki row equal to column. So we can say that all the entries A is where I not equal to j. Then it's called non-diagonal entries. So two type of principal diagonal. First one is our what? First one is our principal diagonal and second one is our non-diagonal entries. So the collection of what? Now let next point. The collection of all entries of matrix A where row number is equal to column number. Okay, is called principal diagonal. And when we say that not non-principal diagonal, and regarding this, come to the conclusion. And conclusion I is equal to, okay, collection of what? Collection of entries A is a pair I equal to j. So we can say that principal diagonal type, and we say that non principal diagonal non diagonal entries. So when entries are when entries are when entries aij where I is not equal to j, so we say that it is the non-diagonal entries. Okay. Regarding principal diagonal, we study about some entries like square matrices. They have order n cross head, and we say that it is the principal diagonal and non-diagonal entry. So this is actually today class I have recorded for campus. Okay, so don't worry about it. So this actually today class I have campus. Okay. Okay. So let us see our next. Wait a minute. So now next topic is our triangular matrices. So now discuss about we are going to discuss about some triangular matrices. So what is triangular? We divide matrices into two categories: upper triangular and lower triangular. When you say that the matrices is upper or lower triangular, the addition. First one is when we say that because their entries, all entries are below principal diagonal are zero. So we said that it is upper triangular and lower triangular. It means a square matrix is said to be lower triangular if it's all triangular above a principal diagonal are zero. So we say that it is the lower triangular. So upper triangular is what? Upper triangular is nothing but all its entries, all its entries below principal diagonal. So we say that it is the upper triangular matrices. And when we say that it is lower triangular, so lower triangular is nothing but all entries above the principal diagonal are zero. Okay, so we say that it is a lower triangular. So upper triangular is what? All its entries below principal diagonal is zero. Are zero. So we say that it is the upper triangular and it is represented like for a square matrices. And if I have some example related to upper triangular. Actually, we are right in this manner. So A is equal to Aij n cross n because it is the square matrix and it is the representation of matrices. Then Aij is for I is j and their entries example like that. A is equal to take as some example like 1, 2, 0, 5. Okay, this is the 2 cross 2 matrices. Take an example equal to 2. So it is the 2 cross matrices and take some another matrix for P and their entries are 0, 1, 0 and 2. This is for B and take M.Sc like that for 3 cross 3 matrices 103, and their entries are 103, 2, and 004. This is upper triangular matrices where all entries below principal diagonal are 0. So basically, this is the representation of upper triangular matrices. Now, about the lower triangular matrices. So, triangular matrix is nothing but all its entries above principal diagonal are 0. So we says that it is a lower triangular matrices. And their condition is what? And their condition is if I take A is equal to Aij for lower triangular matrices, Aij, and that dimension is n cross n, because always take a square matrices representation of triangular matrices. Okay, so triangular matrix is the two types. First one is upper triangular and second one is lower triangular. First one is basically ask about our entries when entries are below diagonal are 0, so we say that triangular, and when entries are above principal diagonals, and when we say that a lower triangular. Okay, and the representation of lower triangular matrix is like this. Take it one example for 2 cross 2 matrices, and their entries are 1 0 2 5. It is the lower triangular matrices. You see here, you see here, you see in place of this, and you see in the place of this. Their entries are above principal diagonal. Okay, these are the principal diagonal, and above entries are 0. So we says that it is the lower triangular matrices. And in 2 cross 2, see, you see that in this matrices, their entries are principal diagonal below principal diagonality. It is the upper triangular matrices and it is the lower triangular matrices. The short triangular matrices are two type: upper triangular and lower triangular. One not related to triangular matrices. Let us see. Note is what? Number of non-trivial entries in a triangular matrices of order. Number of non-trivial entries in a triangular matrices of order, and their entries are n equal to n plus 1 upon me 2. Okay, these are the entries for non-trivial entries for triangular matrices of order n, which is equal to n plus 1 upon 2. Now come to the next matrix, which is our diagonal matrix. Okay, come to the next point, point number 6. And point number 6 is what? Our diagonal matrix. The diagonal matrix is nothing but the matrix where was all non-diagonal entries. So we say that it is the clearly a diagonal matrices, and they are representation like this: Ai is equal to 0, and where for all I is equal to j. These are the I not equal to j. So these are the representation of diagonal matrix. Clear? Any comment related to this? Me, I think visibility is clear or not. To what was this lecture? Actually, there are light issue. So actually, I am recording any children? No problem. Actually, I am in BITS Pilani campus, Hyderabad. Mhm. So, come to the point, which is our diagonal matrices. And what is this? First of all, a square matrix. You have a square matrix, and they are all whose diagonal entries are zero. So, non-diagonal entries are zero. It means what? It uh, matrices. And non-diagonal entries, it means G D1, D2, D3. These are diagonal, and entries all are 0, 0. So we did say that it is the diagonal matrix. So for you see that their dimension is same n cross n, and here is the 3 cross 3 dimension. So order कितना है इसका 3. So we say that is diagonal matrices. These are the example related to diagonal matrix. So one problem related to diagonal matrix. So let us see the problem. And problem is what? Some problem related topic. One problem: find the number of non-trivial entries in a real diagonal matrix of order n over R. Find find number of non-trivial entries in a real diagonal matrix of order n over R. So come to the solution for this question. Now let us see that. Take a one non-trivial entries for real diagonal matrix, and let us some real diagonal matrix like this: D1, D2, D3 up to Dn. These are the entries for non-trivial entries for a real diagonal matrix of order n over R, and the remaining portion is what? 0, and remaining portion is what? 0. These are the n cross n matrices, okay, where di belongs to R, okay, for all 1 less or equal to iota less or equal to n, and their non-trivial entries are number of non-trivial entries are, so number of non-trivial entries in equal to n. What A is equal to n? So these are the problem related to for non-trivial entries, approx order n over R. Now come to the next problem, which is also a complex type entries. These are the real diagonal matrix Okay, the next point is our related to complex trigonal matrix of order n over r. So only changing is what? Changing is just d1 plus iota e1, some complex type entries we have included in a complex diagonal matrix of order n over r. So and their number of non-trivial entries is nothing but a is equal to 2n only. And one problem is very important, and also it is asked in different exam, and their entries are multiply with each other and nothing but. So come to the next point, which is our scalar matrix. So a scalar matrix is what? Our seven matrix is a scalar matrix. So ये स्केलर मैट्रिक्स क्या होता? A diagonal matrix whose all diagonal entries are equal is called a scalar matrix. Okay. An example is what? A is equal to A 0 0 0 A 0 0 0 A, and their dimension is 3 cross 3 matrix is a scalar matrix of order 3. Okay, these are scalar matrices. And a representation like this, when a diagonal matrix whose all diagonal entries are equal is called a scalar matrix. You see their diagonal entries are same, so we say that it is the diagonal matrix. You see here all entries are same. We put A in diagonal place, and their order is 3. Okay, so we say that it is the scalar matrices. Now let a problem is related to scalar matrices. Take one example as a problem. So problem is nothing but related to a scalar matrix. So a scalar matrices over the real entries or complex entries. Okay, nothing but it is the example. So uh, and also five entries is related to this. Okay, so now the problem is what? Find the number of non-trivial non-trivial entries in a uh, real scalar matrix. Real scalar matrix. Matrix of order n. Order n. Matrix of order n. Order n over filled R. Okay. These are the problem related to a scalar matrix of order n over filled R. Now come to this solution for this problem. Which type of matrix? Non-trivial non-trivial matrix of order n over what? Over R. Okay, this type of matrix. So let us see the entries because in a scalar matrix we see that their diagonal entries are same. So it is simple to for you take a and their diagonal entries are same. So it is go on A and it is the n cross n matrices and all entries are 0. So where A belongs to R. Okay. I think campus all are okay. I think it belongs to R and their non-trivial entries are what? Number of non-trivial entries. Their non-trivial entries in A equal to what? Equal to 1. Okay. Matrix n cross n. Now come to the next problem and diagonal matrix of order n and or we ask actually question ask about if any matrix of n and commute with every diagonal matrix of order n. So when we commute it is show their properties of scalar matrix. So we study this question in next, but one important problem which is basically asked exam and which is also related for commute every diagonal matrix of order n. Okay, so let us see the problem related to this problem. Okay, and it is also a type of a scalar matrices. So what problem? But let us see the problem. Find the number of non-trivial entries any chats clarity is visible or not. No chats. 2% actually watch but no one comment and light visibility is not clear. Only one person is what watch this class. Okay, only one person is what. So let me check where the light is on or not. Now I check a key. Hmm, light is on. The light visibility is clear or not. Let me check it. Okay, come to the point. We see here a problem related to scalar is what their diagonal entries are set. So this problem find a number of non-trivial entries non-trivial in S, and S is entries are a 3 cross 3 type matrix, and AD is equal to DA over R, where D is equal to diagonal 4, 5, 4 type. Okay, come to solution. First, we take a non-trivial entries like for 3 cross 3, and their entries are commute with every diagonal matrix this AD equal to DA over R, where D is equal to diagonal of entries there are 4, 5, 4. So how you solve this question? So here we see that since AD equal to DA, these are the relation where such that for A 3 cross 3 matrices. Now check. So that is we check some 3 matrices and their entries in 4 diagonal type. So first of all, you A11, A12, A13, okay, A21, A22, A23, and next one is what? Wait a minute. Let me arrange this. A31, A2, and A33, and their entries is like this. 4, 5, 4 type. Okay, so 4, 5, 4. It is also 4, 5, 4 type, and it is also 4, 5, 4 types entries. You see here all column and their entries are same, and in a row 4, 5, 4 type. Okay, this is also 4A23. This type of entries for AD. Okay, now when we commute, then it will be interchanged like this. Someone call me, wait for a minute. For A11, for A12, then for A31. Okay, 1, 3. And second it 5A21, 2, 5A33 type. And the third one is what? A3, 4A32, and 4A33. These are the interchange their diagonal entries. So it is also come in format of 454 type, their diagonal entry. So we see that here points are in format of A21 equal to A21 equal to sorry A12, A12 equal to A21, A23 equal to A32 equal to 0. These are linearly independent type vector space type entries in constituent any matrices which will be used in our such a linear combination equation type. Okay, we actually these are used for linear combination type of entries, and it shows that the diagonal entries or the vector is what the vector entries are linearly independent. When one is not equal to zero, then we say that it is the it's for the field over the scalation, okay, for a scalar multiplication, and a scalar multiplication ask in our field type. Now there the non-trivial entries like this, and now come to the next slide. Therefore, A is equal to where A11, A13, A22, A31, A33 belongs to R. Okay, and number of non-trivial entries equal to 2 square plus 1 square equal to 5. Now come to the next problem, which is basically ask and find its non-trivial entries, and also their entries are and commute with every diagonal matrices. Okay, so come to the next matrices, which is actually identity matrix or unit matrix. So how you say that it is the identity matrix or unit matrix? Because their diagonal are one or unity, so we say that it is the identity or unity matrix.